Hello students, I welcome you all to Engineers Academy. Do subscribe my channel if it helps in your learning. Now we are going to solve this problem which says that the tongs are used to lift 150 kg crate whose center of mass is at G. Determine the least coefficient of static friction at the point blocks so that the crate can be lifted. So now we have this tong and it is used to lift this 150 kg crate, and here the external force is applied, which is P. So we have to find the coefficient of static friction at this point A and B. So now it's a kind of a design problem, right? So now if we observe this whole mechanism, then in order to hold and lift this crate, this part of the tongue need to apply the force on the crate in this direction, right? So from both sides we need to have the normal force on the crate in this direction, that is in the horizontal direction. So now I have cut this tongue into three different parts, right? Into three sub parts, right? So this is arm ACE, this is that this particular joint, and then we have that crate itself. So now at crate, this portion of the tongue will apply the force on this crate in this direction. So we will have, let's say this will be the normal force applied by this portion in this direction. So this is at point A, so this is an A, and then we will have an B. From the other side we will have an B, and then in order to provide the crate from slipping down, this surface at A and B will apply the friction force in the upward direction on the crate. So we will have the friction force in the upward direction like this, and similarly we will have the friction force in the upward direction like this. So this will be FA and this will be FB. So now if this part applies the normal force on the crate in this direction, so as a reaction this box will apply the same force on this part in the opposite direction. So we will have that an A force in this direction here. So this is that same NA, and if the friction force applied by this part on the crate is in this direction, so as a reaction the crate will apply, or the crate surface will apply the same force on this direction, right? So we will have the FA acting in the opposite direction, since these are the action and reaction forces. So this is FA, and then since here we have the pinch joint, so we will have the support reactions. This will be our CX and this will be our CY, since we are assuming that this is our positive X and Y direction. Now in order to have the normal force on the crate in this direction, we need to have the force at point E in this direction in order to rotate this ACE arm like this. So in order to produce a counterclockwise movement, this HE arm is going to apply the force at point E in this direction. So we will have the force at point E like this. We will have the force like this. So this will be our force applied by HE arm at point E. And if this arm is applying the force at point E in this direction, so as a reaction, this arm is going to apply the force on this joint H in the opposite direction. So we will have that same FHE force but in the opposite direction. So this is that same FHE. This is FHE and this is FHE. And similarly on the other side, since this whole mechanism is symmetrical about this line, so on the other side we will have this same force, FHF force, which is going to act like this. So again we will have the force at joint F, and let's say this is FHF, and this is the force applied at point F, and as a reaction we will have the force in the opposite direction at joint H. So let me show the reaction force on joint H. So this is our actual force. So now we have considered all the forces, and if I draw a horizontal line here at point H, so we have this angle equal to 30 degrees. So if this angle is 30, this angle is 30, and this angle is 30. So now I will write that considering, let's say this is my, this free body diagram is, let's say, my free body diagram A. So from A, and in order to lift this box, the whole system need to be in equilibrium, right, in order to lift it, right? So to find that least coefficient static friction, this crate need to be in contact with that point A and B, so it must not slip, right? So for that we have to find that mu s. So since the crate is stationary and it is kept at that AB position, so we are going to consider the equilibrium condition. So we are going to apply the summation of forces along x, y, and the summation of moment equals to 0. So now for figure A, for this particular figure, if we apply the summation of forces along x, that must be equals to 0. And now for that we have to resolve both of these forces. We have to resolve this force and this force. So now if I resolve this FHF, so we will have this cos component, this one will be FHF cos of 30, since we have 30 degree here, and then we will have this FHE cos of 30, since this angle is 30. So the summation of forces along x equals to 0, so we can say that FHE cos of 30 is equal to FHF cos of 30, and from both sides cos of 30 will cancel out, so we can say that FHE is equal to FHF, and let's say this is equal to force F. Since both are equal, so we can say that let's say that the magnitude of both of these is equal to F. So now we can say that this FHE is equal to F. And now if I apply the summation of forces along Y equals to 0, this is our positive Y direction. So now we can resolve, we can have the components of both of these forces in the Y direction. So we will have this component, this one will be the sine component of FHF, this will be FHF sine of 30, and we will have one another component like this. So this one will be the sine component of FHE. So now since both are equal, we can say that this is F sine of 30, and we will have again one another F sine of 30. So we have these two components. So now the summation of forces along Y will be equal to, since this P force is acting in the upward direction, so we will write plus P minus 2F minus F sine of 30. Let me write it like this. This is F sine of 30. Since this component is acting in the downward direction, this is acting in the downward direction. So minus F sine of 30 and minus F sine of 30. This is equal to 0, and adding both of these, that will give us minus 2F sine of 30. And now if we know this P force, the external force, so we will be able to find that F, the force which is applied by the arm in this direction and this direction. So now to find P, we need to consider this whole mechanism as one body. So now we can show that the weight of the crate is going to act at its geometric center. We will have that weight here, and this weight is 150 times 9.81. So now if you consider this whole body together, so we can apply the equilibrium conditions, and we can say that the summation of forces along Y for the whole body, that must be equals to 0. The summation of forces along Y equals to 0. So is we are considering this whole body together, since at every point we have the action and reaction forces, so they cancel out each other. If we look into this all these free body diagrams, so we have this FHE, so this is FHE, they cancel out each other. We have an A, we have an A, so all of these cancel out each other. So the summation of forces along y for this case, so again P is acting in the positive y direction, so I will write plus P, and the weight is acting in the downward direction, so that is in the negative direction, so that is 150 into 9.81, this is equal to 0. So from this we can say that P is equal to the weight of the crate, which is 150 times 9.81. So now from this equation we can say that minus 2f sine of 30, this is equal to minus P, minus will cancel out, and from this we can say that F is equal to P divided by 2 sine of 30. And now P is the weight, which is 150 times 9.81 divided by 2 sine of 30. So 150 multiplied by 9.81 divided by 2 sine of 30, this gives us F equals to 1471.5 newtons. And if I calculate the P force, which is 150 times 9.81, this is 100, P is equal to 1471.5 newton as well. So now from this equation, since sine of 30 is 1 divided by 2, so 1 divided by 2 will cancel out these 2. So ultimately we will get F equals to P, which is equal to the weight. So now we know the F force which is applied at this point E. We know the magnitude of this force F, which is again equal to the weight of the crate. So now after this we are going to consider this ACE arm for further calculation. Now we are interested to find this NA, and we are interested to find this FA. So this FA will be, we know that this FA will be equal to mu S, which is required, times NA. So now we are going to consider the ACE arm. Let me write that ACE arm. And now we are going to apply the summation of moment about point C equals to 0, since at point C we have Cx and Cy as unknown. So by considering this equation, they will not come into our calculation, since they are not producing the moment about point C. So we are assuming that the counterclockwise moment is positive. And now to apply the summation, to find the moment about point C, we have to resolve this FHE, which is equal to F. So again we will have two components of this FHE. We will have one component in this direction, and we will have one component in this direction. And again we are having 30-degree angle here. So now this one is the cos component, this one is the sine component. So now to find the moment about C, this cos component is producing the moment in the counterclockwise direction. So I will write plus F cos of 30, and the perpendicular distance of this cos component from that point C is 500 mm. So I will multiply it with 500. Or if we convert this 500 into meters, then this will be 0.5. So let me multiply it by 0.5. So this is 0.5 meters. And we know that F magnitude, we know this F magnitude, which is 1471.5. So let me write this as 1471.5. Now this sine component is also producing the counterclockwise moment. So again I will write plus, and that is F sine of 30. So now F is 1471.5 sine of 30. And the perpendicular distance of this component from that point C is this distance, which is 275. This is 275, right? So I will multiply it with 0.275. 275 divided by 1000 is 0.275. So I'll multiply it with 0.275. Now this NA is producing the clockwise moment about point C. So I will write minus NA And the perpendicular distance of this NA from that point C is 500, which is in meters is 0.5. And similarly, this FA is producing the clockwise moment as well. So I will write minus, and FA is mu S and A times the perpendicular distance. Now the perpendicular distance of this FA from that point C is 300, so which is 0.3. So I will multiply this with 0.3 in meters, and this is equal to 0. So now in this whole equation we have mu S unknown and NA unknown. So now let's simplify this. We can add up both of these terms. This will be, let me write this is 1471.5 multiplied by, if we take 1471.5 common from both of these, so we will have the equation like this. And I will erase this. So now we can say that this is 1471.5 into 0.5 cos of 30 and plus 0.275 sine of 30. So this is 839.509 minus 0.5 and A, and minus mu S and A, let me write this as 0.3 times mu S and A. This is equal to 0, or we can say that this is minus 0.5 and A minus 0.3 mu S and A equals to minus 839.509. If I multiply this whole equation with minus sign, so we will have everything as plus. Now this is one equation and we have two unknowns, and A is not known and mu S is not known. So now we have to consider the free body diagram of the crate. So now if we consider the free body diagram of the crate, again the crate is in equilibrium, so we are going to apply the equilibrium conditions, and again we can say that the summation of forces along X must be equals to 0. So now as we can see that this NA is acting in the positive X, this is acting in the Y, so we can say that plus NA minus NB equals to 0, and from this we can say that NA is equal to NB. Since the whole mechanism is symmetrical, so on both sides we will have the same NA, we will have the same normal force, so NA is equal to NB. And similarly, if we apply the summation of forces along Y, so in this free body diagram the weight is acting at G as well. So let me show that weight, which is very important, and this is 1471.5 newtons. So now if we apply the summation of forces along Y for crate, so this is our positive Y direction. So now we have FA plus FB minus the weight, which is 1471.5. This is equal to 0. And if NA is equal to NB, then FA is equal to FB, since the coefficient of static friction on both sides is also equal on both sides, and NA is equal to NB. So now from this we can say that if FA is equal to FB, we can say that 2FA, let me write that from this FA is equal to FB. So 2FA is equal to 1471.5, and FA is equal to 1471.5 divided by 2, and from FA we can write that this is mu S times NA equals to, so 1471.5 divided by 2, this is 735.75. This is the product of mu S times NA. This is equal to 735.75. Now if we look into this equation, so we do not know mu S, we do not know NA, but we do know this product. So now we have to substitute this in this equation. So now we can say that 0.5 NA plus 0.3 times mu s times Na is 735.75, and this is equal to 839.509. So from this we can say that 0.5 Na equals to 839.509 minus 0.3 into 735.75 divided both sides of the equation by 0.5. So this we will get Na. So now Na is 839.509 minus 0.3 into 735.75 divided by 0.5. So Na is equal to 1237.568 newtons. And now we know that mu s times Na is equal to 735.75 from here. We know. And so we are interested to find mu s. So that will be mu s equals to 735.75 divided by Na, which is, this is 1237. This is 1237.568. So 735.75 divided by 1237.568. So this gives us mu s 0.595, let's say. So we can have this minimum coefficient of static friction equals to 0.595 for the crate of weight equals to, for the crate of mass equals to 150 kg crate. We can have the coefficient of friction greater than this mu s value, but we cannot have a mechanism, or we cannot have a tongue which have the mu s value less than this. So this is the least value which will enable the tongue to lift the crate safely. So we need to have such a material here at point A that should at least provide the coefficient of static friction equals to 0.595. Otherwise, the coefficient of static friction less than this will not work for us. So this is the solution of this particular problem. I hope it will help you in your learning. Let me know in the comments if it helps in your learning. And do subscribe Engineers Academy for the solution of such more problems from Hibbeler Statics. Also recommend my channel to your friends and colleagues so that we can reach out many more students.